How to create your own Python stock screener. First, we're going to be importing some modules. NumPy, Pandas, and IB-InSync are some of the modules necessary. Next, we're going to be setting up the API connection to Interactive Brokers. Make sure to get market data permissions and download the Trader Workstation desktop app. Step 3 involves pulling the stock data from the Interactive Brokers API using ib.recHistoricalData. We can specify any time interval we'd like, as well as any stock price. In this case, we'll be using SPY. We transform the data into something a little more usable. We're going to be making a separate data frame for each time interval we had specified. We're going to do the 9:30 a.m., noon, and 4 p.m. data frames. This will make it easier in our next step to compute some values. Step 5 involves calculating the average and standard deviations for each of the individual data frames. We can do this through NumPy. After computing these values, we can plot out the data to view valuable insights on how SPY has behaved for the past time interval you had specified in the data pool. Next, have fun with it. This is where we can get creative. We're going to expand on different concepts in future videos. So now we'll get into the details here on how this will actually work in Python. So I've got my Jupyter notebook here with all these sections divided up, and we'll go through each one line by line, starting with the imports. So first we'll do from IB-InSync import all. This will form the actual connection to Interactive Brokers. Pandas as PD, import NumPy as NP, import datetime as DT. So just establishing some standard imports. From datetime, import time delta, import nest async IO. So this is a big one. I'll talk about this in the next section. Import random, and finally import plotly.graph objects as go. Okay, I like using Plotly a little bit better than matplotlib. I think it looks nicer, so that's what I prefer to use. The first thing we do is net asyncio.apply. And what this does is it allows you to run nested event loops in Python. Python's default is to only have one event loop running. However, this enables you to run a nested event loop. And an event loop will be created when we establish the connection to Interactive Brokers. So this is crucial. If we don't do this, the code won't run properly. So now forming our connection here. And we're just getting this established, this connection established. So random.rand int. I'm just going to pick a random integer. This will be our session client ID. There's probably a better way to do this, but this is fine for the purpose of what we're doing. 127. This is the socket port, so I'll show you in the Trader Workstation right after I type this out. Okay. Perfect. So we're connected now. So we're in the Trader Workstation desktop app at the moment, and really the only thing to know with this is go to Edit, Global Configuration, API, and then within Settings, you want to enable ActiveX and socket clients. It will come with this checked, but you want to uncheck the read-only API, and then I change this socket port to 7496. So as long as this number matches what's in your code, then you'll be all set. And now we'll go back to the code. And now moving on to pulling the stock data. The way it works is it defines these connections as contract. So you establish the contract, and then you give attributes to it. So for example, the symbol, which we'll be doing SPY, and you can use any ticker you'd like, contract dot securities type stock. You can do options as well. SPY contract dot exchange, and just use the smart exchange. It's the easiest. And next dot currency. I will be using US dollars. Okay, that's all set right now. So we have all the attributes established. What we want to do now is pull the historical info by using ib.request historical data. And here we put the contract. The next argument is empty quotes to go to the present day, and then how far back you want to go with the time interval you'd like to specify. So we're going back 10 days and pulling every 5-minute interval. Then we'll do ask, and I'll show you in the documentation what these final arguments mean. False, empty list, and then a 0. Okay. So going to the documentation, we have the ask here. This is true to pull only regular trading hours, so that's what we did. And then set this to 2 to have the UTC time zone. So I like to just start with this and then manipulate it into any time zone we'd like. So we have false for this, then we have an empty list, and finally we set this to 0 to wait indefinitely. So those are our settings here. We'll convert this into a data frame. So SPY-DF equals pd.dataframe SPY historical info. Perfect. And we'll show you what this looks like. Okay, so we have, starting at, this is 9:30 Eastern Standard Time, the 9:35, etc. The SPY open, high, low, and close for each 5-minute time interval. And this spans 10 days. So this would be that first day, this would be the 10th day, or the day closest to us. So 10 days ago, and then today. Okay, great. So this is what the data frame looks like. Now we're going to manipulate the data frame a little bit. We're going to add on to this. We're going to say close move equals, and this will just represent in this 5-minute interval the closing price, the open price to the close price in percentage terms. And the way we calculate this is SPY DF close divided by SPY DF open. Then we're going to subtract 1, multiply this by 100, so it's a percentage. And then we're going to add, okay, so here. So now that we have that written out, I'll show you the data frame again. And we have this extra column here, close move. So perfect. So now we're going to start on the time manipulation portion. What we're going to do is convert this UTC time into Eastern Standard Time. So we'll write out SPY-DF. We're going to add a column for Eastern Standard Time. In this column, we're going to take the current date time, and we're going to subtract 5 hours, because that's a conversion from UTC to Eastern Standard Time. And then we're going to strf time. This converts the column into a string, and I like 12-hour time, so we're going to use this format. This is how you do 12-hour time with the AM and PM shown. So you've got that. I'll show the data frame again. Okay, perfect. So we've got this Eastern Standard Time column. And now we'll do time list equals SPY df dot unique. So this will pull all of the unique values from this column, which will be from 9:30 all the way till 3:55. Okay, perfect. In this next section here, we'll be calculating the average and standard deviation for each of these time intervals we specified. So we'll start off with an empty list, and this will be filled with data frames for I and range length time list. So for all these individual times, it's going to go through, start at 9:30, then 9:35, etc., all the way to 3:55. And we're going to do this. So we're going to add data frame to the list where SPY df time EST is equal to time list of that given index. And then we're going to drop NAs, we'll say how equals all, and reset index. Okay, perfect. So now if I print out, so what this is doing is just creating all these individual data frames. I'll say df list 0, which will represent the 9:30. So for the past 10 days, these are all the 9:30 time points. And I can do this with, let's see, so 9:55, and so on. Okay, so now that we've got that, we are going to calculate the standard deviation and average on each of those data frames. And we'll do that by first creating an empty dictionary. We're going to say for I and range length df list d close move. So we're creating a new column called close move standard deviation, and then labeling it with the index like this is equal to np.std, so just a numpy function for standard deviation of that given data frame at that index on the close move. We're going to copy to average function, and there we go. So we have the dictionary list, but now we're going to make this a data frame by doing pd.dataframes. We'll do name is equal to d.keys, and the value is equal to d dot values. Okay. You can print this out to see what it looks like. Okay, great. Now, we're going to break this into two separate data frames. One is just containing the standard deviation, the other has the average. So we'll say close move standard deviation equals, we're going to use the where function again, where df name, and then this time we're going to use a function contains, so where the string contains these characters, close move std. So wherever that happens, it's going to pull those, and we're going to drop an a and reset the index. And we're going to just copy and paste this and do the same thing, but with the average. Close move average. Okay, perfect. And we're going to add on the Eastern Standard Times to these data frames. So close move std time est is equal to time list. And we're going to do the same thing. For this data frame. Okay, perfect. I'll print one of these out so you see what it looks like. Close, move, average. So we've got the value and the time. This average is the percent change for 9/30, the aggregate of those past 10 days. So in the final couple sections here, we've got the average plot and the standard deviation plot. I have them plotted ahead of time. I'll review the code here. So we established the figure, and X is going to be the Eastern Standard Zone time. And on the Y-axis, we have the average value. We're going to do a line plot here, and specifying some layout options. What we're going to do is adjust the ticks on the x-axis, making it a delta tick of 8, just so it's spaced out a little more as opposed to labeling every single x value. I think it looks a little cleaner that way. And then we give it a title, close move average for the past 10 days. This centers it in the middle of the page. And then if we show the plot, we see the average SPY price for the past 10 days at each given time. So on average, so at 9:30, it has typically gone up. 2 p.m. it's typically gone up. Looks like there's some drops at 10:30, and if we look at the standard deviation, which is the same code, just replacing the standard deviation here, we can see something interesting. 2 p.m. very high standard deviation. This is because of the FOMC meeting, so causes a lot of variation there. But there you have it. So hope you enjoyed this, and I'll be doing some videos in the future, more data manipulation with the Interactive Brokers API. And thank you for watching. If you enjoyed this, please like and subscribe, and hopefully we'll see you in the future. So thank you.